Charging.
All right. Hey, success. So welcome. This is aerial images to maps, or technological advances that we've been doing with OpenDroneMap. I'm Piero Tofanin. I'm one of the co-founders and the lead maintainer on the OpenDroneMap project. By quick raise of hands, who has used OpenDroneMap before? All right, all right. So that's more than last time. So that's that's very good. A quick introduction for those that have not used or seen OpenDroneMap before. It's OpenDroneMap. It is open, as in free and open source. It has to do with drones, although it is not its only use case. You can, in fact, use virtually any camera that you'd like to use it, including your phones and GoPros and other cameras. And it does create maps. And by maps, we mostly mean true Earth photos, but that is not all it does. And I sometimes like to peek around Twitter to see what people tell about OpenDroneMap, and apparently it's also the best thing to happen to UAVs, since drone and UAVs. I didn't say that. One of you did. So OpenDroneMap is not a single project. It is actually an ecosystem of tools. It is free and open source. It has been actively developed for the last 8 years. It has excellent support, even commercially supported. It is well documented, and it's comparable as of late, and sometimes even better than proprietary alternatives. We pride ourselves in having a very friendly community. We put a lot of effort to build that. And if you are new to the software and you just want to get a peek and get started, OpenDroneMap.org is all that you need to access to get a glimpse into the ecosystem. The main tool that we develop is a fully automated processing pipeline that takes raw images, like the ones that come out of drones or your phone also. Provided that those pictures have sufficient overlap, we are able to do a process that I will quickly make an overview of. And it's able to generate several different assets which are of much interest to geographers and surveyors and many other industries. Those include orthophotos, elevation models, point clouds, and textured 3D meshes. Some of the examples that you can find from people around the world using OpenDroneMap include mapping longhorn cattle areas to see where they're moving, or making digital surface models of archaeological sites. It includes the ability to make measurements on 3D point clouds, computing plant health map indices. All of this is done through the software, through a GUI that we've created for the software. So all of these screenshots are directly from the software that you can download from OpenDroneMap. You can also process very large data sets. In fact, we are probably one of the softwares that can process the most images, provided you have the right setup. There's a screenshot there of this awesome picture I found on Twitter that they processed some 1.4 billion point clouds organized in a COPSI format, and they opened it and recorded a video straight out of QGIS, which is fantastic. And you can also use it for less, how did you say it? more fun projects. For example, you can shrink your house and 3D print it and hold it in your hand, and that's kind of cool. So you can do that also with OpenDroneMap. You can also create very cool isometric designs if you open your models in Blender and do some cleaning to make it look pretty. So that's also kind of cool. To get started, you just need a drone. You capture some images. If you don't have a drone, you can use your phone. If you don't want to use your phone, we also have test data you can just throw into the software to try it out. To download the software, there are simple instructions that you can find in the documentation. You can also help fund the development. We have a small installer that people can purchase, and that helps you get up and running even faster. So that's also an option. Once you've selected your images and tossed them into OpenDroneMap, you just need to wait or go get a coffee, and you should be up and running. This is a bit what the interface for the program looks like. You can see that there's a big button. You can't miss it. It says select images. It's quite simple. You select all the images, You review your information. You can choose whether you want to process your data locally or you want to send it to, say, one of your other computers that maybe it's set up in the cloud. You can do that also, so you can distribute your tasks across multiple machines. After you're done choosing your options, you can press review and start processing. The process will take a bit depending on how many images you have. We have to be realistic. If you're trying to process 10,000 images, it might take a while. And by a while, I mean maybe a day. So if you try to process a more reasonable amount, which you can usually do, you can probably process it in maybe a few hours. If you have 18 images like here, it'll probably process in a few minutes. So the time required to process increases linearly, roughly, with the number of images. Once you are done processing, you will be presented with the results. Through the interface, you can explore your Earth photos. You can look at your plant health. You can compute various plant health algorithms. Something that is new that I want to mention very briefly is we've added this very nice export features directly onto the map. It's a what you see is what you get export. So if you change the sliders around your map and you want to exactly print out a copy of that geotiff in RGB, or maybe you want to export it in JPEG, you can do that now. So that's very helpful for getting information to stakeholders and other people that might be interested in the result without having to install other software. You can also check out your surface model and finally your 3D models from which you can make all sorts of measurements and annotations. So very briefly, I really worked hard on this slide because my first attempt was very long. So I started deleting as many things that I could to really simplify it. In a nutshell, what we do is we take images and we run them through a process called structure from motion. From there, we are able to estimate the original camera poses of where the pictures were taken. We further then pass all that information into another process called the multi-view stereo. This gives us a densified point cloud. From there, we apply algorithms for meshing, texturing, and we obtain a textured mesh. And finally, we take a picture from above, and that gives us our final Earth photo. Plus, all the rest, which gives us the georeferencing and the ground control points and rolling shutter correction. And, but in a nutshell, this is what it does, and it's quite fascinating and magical if you've never seen it. So, what is new about OpenDroneMap that we've added in the past few years, or since last time that we've been at a FOSS4G event? The biggest thing that we've done is probably the most impactful because we've finally been able to get OpenDroneMap to be a first-class citizen on Windows. It used to be the case that you need to use another program called Docker to get it up and running. That is no longer the case. You can run OpenDroneMap fully natively on Windows with the GPU acceleration and all the goodies without having to use Docker. And it works really, really well. You can download the ODM program directly from GitHub. You just head to the releases page, and we have set up the installers to download directly from there. We've also made major efforts to speed up the pipeline in general. So if you've tried OpenDroneMap, say 2 or 3 years ago, and you try it today, you will likely notice a very shortening of time in the processing. And one of the things that contributed to this massive acceleration has been the introduction of GPU acceleration. If you have an NVIDIA card, you can now use that to speed up several steps in the processing pipeline. It is enabled on default by Windows, so you don't have to configure anything. It will just work. TM, trademark. If you're on Linux, you simply need to use a different Docker image. The default one will only have the CPU stuff. To get the GPU stuff, you need to use a different tag. But it's pretty straightforward there as well. Another big thing that we've added in the topic of speeding things up is we've added planar reconstructions. If you have a data set that has been captured on a flat terrain, for example, anybody that does things and surveyings in agriculture, this is typically the case. And you've flown your drone at a fixed altitude, which is also frequently the case. And you've taken nadir shots, meaning you took all of your pictures looking straight down, which is also frequently the case. You can turn on a new option called SFM algorithm planar. And this new mode will allow you to get reconstruction results much, much faster because it has been massively parallelized. So if that is your case, definitely check it out if you haven't. Other things that we've done is we now create much denser and accurate point clouds. This is mostly credit to the people at OpenMVS, which our project relies on. And it is currently the best verifiable score on one of the key benchmarks for structure from motion benchmarks. So very, very cool in that regard. And you also have a new option called PC Geometric. Turning it on will definitely improve all of your reconstructions that involve the presence of buildings, so man-made structures. It will really fine-tune and sharpen the point cloud edges to show those geometries. And the people noticed. It's not just you, class. I think it's everyone. We've added state-of-the-art support for multispectral images. We have automatic band alignment. We've started adding support for several camera vendors and sensors. OpenDroneMap will take care of sorting out all of the file mess that is a multispectral data collection. You take all of your images and you toss them into the software. The software will figure it out how to give you a single orthophoto multiband that is giving you reflectance values. Radiance values. So it also is able to ingest a mix of RGB and TIFFs, even with redundancy. So if you have RGBs and you have individual R, G, and B bands in form of TIFFs, OpenDroneMap will sort it all out and still give you a good result. You can turn on and off the radiometric calibration by specifying the radiometric calibration flag. We also have thermal support, so if one of your multispectral bands includes thermal bands, we will also process those. The visualization of the thermal information is still experimental, but it is available. It's kind of hidden. We get a lot of requests about that, and we will improve it. You currently access it by going in the plant health tab of the GUI. So it's not really straightforward, but it's there. If you go into plant health and you look for the thermal band, you will find there a way to visualize it. We've added support for cloud-optimized point clouds. If you've seen Howard Butler's talk yesterday, this is an amazing thing for point clouds in general. If you don't know about COPSI, go check it out. This is something that we have enabled in OpenDroneMap if you pass an additional option while you process your data. It will just generate the file for you, and then you can use it with all of your tools that have COPSI support. We've also added support for generating OGC 3D tiles. This is not something that we do with a cloud service, whether proprietary or open. This is all done offline by OpenDroneMap, and you can generate them automatically, both for the 3D meshes and point clouds by enabling a flag. And the meshes are not just the normal meshes wrapped into 3D tiles. These are actually hierarchical level of detail meshes that will stream efficiently, even if your model is really, really large. And it's also, as a bonus, available as a standalone module. So you can go on GitHub in the OBJ2Tiles repository, and you'll be able to download it and use it without the rest. We've added support for the ARM64 platform. This means that you can use OpenDroneMap on your Apple M1 and M2, and you can also deploy it on servers that may be using the newer ARM chips. So that's been really nice. We've added, we wanted to add this just because we could say it. OpenDroneMap is now a machine learning program. We have machine learning in OpenDroneMap, and it's very advanced. No. No, we found a use case for AI, and it works fairly well. If you have taken pictures of the sky because you're taking horizontal pictures of a facade, that is often the case for inspections of various structures, and the sky is in your background, you will often get various outliers in your reconstructions. You can now turn on a flag, and we will use an AI model to create a mask for you, so you don't have to, which is really nice, and it works. We also have an option to restrict the boundaries of your reconstruction so that say that mountain over there that you see on the screen doesn't get reconstructed and leaves your building looking very tiny. It will automatically create a reasonable bound for your reconstruction. We finally implemented a much asked feature, which is rolling shutter correction. This has been on our feature requests list since 2016, I believe. So it took a while, but we got there. Rolling shutter is very useful if you have a drone that has a rolling shutter camera and you are taking the pictures while you're moving the drone, which is often what you want to do because you can capture your photos more quickly. Hovering and taking pictures takes a while, so this was very, very helpful. You can now turn on a flag, rolling shutter, and ODM will increase the accuracy of your rolling shutter reconstructions automatically. We do need to know from OpenDroneMap what is the sensor readout time of your camera, and we have a crowdsourced database that gives us the values for dozens of cameras already. If you do not have that value for your camera in the database, we also provide instructions on how to build a simple Arduino device that will let you figure out what your sensor readout time is. It's a very fun weekend project. You can do it with your kids. They'll love it. And you get to contribute to OpenDroneMap. So definitely check out the RS calibration repo if your camera is not in our database. And together we'll build the best rolling shutter database. Now, I want to quickly mention that OpenDroneMap has been able to make great technological advancements, even with a much more limited set of resources compared to other companies. And I wanted to say that this is possible because of our modular nature and our ties with other open source projects. So even though OpenDroneMap, the people that work in OpenDroneMap to put all these pieces together, maybe a small team, the people that contribute to the overall software is quite large. And as I started to making this list, I ran out of space. And I'm sorry if we're using one of your packages and your name is not here. This is mostly a list that came from memory, but it involves many people that have contributed many modules that have ended up in OpenDroneMap. So it's really a global effort. I want to quickly touch on how we approach contributions. As a project, we're very welcoming of help from the outside and to contributions. We actually have a mantra to place people before code. That means that we're not particularly picky about whether you're going to use tabs or spaces. Or whether a particular function is not implemented according to how we would really like to see it. In general, we follow a simple flowchart. Does it break? No? Accept it. But? No but. You can always make changes later if needed. If it does break, yes, we will ask you to try to fix it, but we'll help you along with the way. So our approach has been mostly to merge pull requests quickly. We believe that this encourages people to contribute more. And we try not to ask for too many changes unless it's broken or it's completely out of scope. Like, don't put email in OpenDroneMap. We will not merge it. All of this takes quite a bit of effort, but we believe it's worth it because we think the people are really the soul of the software. Code comes second. I want to have we have one final surprise that has been years in the making. And so I'm going to leave the final few minutes of the presentation to Stephen Matter. He is the co-founder of OpenDroneMap. He's been the one that started the project. So let me introduce Steve.
So I feel like the luckiest person in the room. Is Michelle Tobias in the room? Michelle is user number 1. And so I presented at FOSS4G in Portland some half idea of a project, and afterwards they dragged me into the hallway and said, oh, we got to this step. What's the next step? So beyond that, we had DK Benjamin manage it for a while. We had Piero show up. We have Luca. We have that long list. Actually, Piero doesn't know this, but I started to generate, based on the GitHub repos, the full list of, like, a scrolling list of everyone, and I gave up. I could do it for some of the projects, but particularly for Goodle, Poodle, Leaflet, it was just hopeless. It was thousands of contributors. So really, this is a larger community effort. And what we want to do within the context of OpenDroneMap specifically is continue to resource the community outreach and the support of the community through dedicated support. So more information to come, but an org is incorporated. The board is in formation. The application for 501c3 status is, will take 3 years and be a nightmare. But in the meantime, we're going to be doing more work and more dedicated and focused work in this space that complements the rest of the orgs in the space that are also doing fantastic stuff. So TBD, more to come, and we'll talk about, I think at future ones, we'll talk about economic models and ways to do this. And I think this aligns with things that other projects are currently either already implementing or beginning to implement in their space. So,
excellent. Thank you so much, Steve. All right, that is it. So thank you so much for attending. Do we have a few minutes for questions?
Oh, of course, yes.
Okay, wonderful.